So what I want to really emphasize to all of you is in lesson 7, if you think you're getting you're doing the computations correct, but for some reason it's not accepting whatever it is you're putting in, that's when you hit message instructor. Okay. Just a reminder, lesson 7 online homework is due tonight by midnight. We're going to be wrapping up lesson 8 today in class. Oh, Wednesday. Sorry, I thought today was Wednesday. Don't listen to me. What the heck do I know? Thank you. Yeah, lesson 7 is due tomorrow by midnight. I guess it was wishful thinking that today was already Wednesday. Let's see. We will be finishing up lesson 8 today in class. Lesson 9 is a very, very, very short section. Like I would venture to say everybody's done it before. But the ideas I'm going to talk about, and they're important because we're going to need them in the next few sections where we do statistics. Okay, but going back to the binomial, just one more example that I'm going to take us through is as follows. And this is similar to probably what you had in lesson number 4 of your lesson 7 online homework. Okay, so what this person's numbers were given was 10% of a group of people, I guess, are left-handed. And they looked at a total of 11 people. And various probabilities want to be found. So of those 11 people, they want us to find the probability that exactly 5 are left-handed, exactly 9 are left-handed, at least 7 are left-handed, and at most 10. This kind of takes us through the important calculator functions that you need. Okay, so notice when you have exactly, that's a binomial PDF. Okay, so literally what you're going to do here is compute binomial PDF. There's a total of 11 people. 10% are left-handed, so I'm going to put the 0.1 because they want it in decimal form. And then here I would enter 5. The only difference for the next one is I would have this binomial PDF, but here I would have exactly 9. So if I'm going to plug it into a calculator, and I just grabbed the first calculator I saw in my office, which was this one. You're going to go to the binomial PDF and literally enter each of those values. So for this one with exactly 5, again, notice it's binomial PDF. I'll hit enter. And for this one, I get 0.00. If I go to 4 decimal places to 5. When in doubt, put more decimal places rather than fewer. The program's probably more likely to accept that. But again, if you have essentially the right answer and you're being marked wrong, totally message instructor, like, please don't be frustrated. At least about that. So for the next one, it's binomial PDF again. Again, when you have exactly, it's that PDF, and my N and my P are not going to change, but now I want 9 of them to be left-handed, and it's not very likely. Notice here, I get 4.455 E negative 8. The computer program is probably going to want me to put this in decimal form. So I'm going to need to move my decimal point 8 places to the left. So 2, 3, 4, 5, 6, 7 zeros, and then 4, 4, 5, 5. It might be the case that if they just want you to round to 4 decimal places, you could just put a 0 here, because rounded to 4 decimal places, you would just get a 0. You with me this far? If you have a question, yell out. And those of you on Zoom, perhaps yelling might not be very effective, but you can certainly chat out. Okay. Okay so far? All right. Now you also know why I don't put like a lot of these on tests, because it's just pushing buttons and yeah, anyway. Okay, at least 7. Remember, at least means that you have to do the complement. At least 7 means 7 or more. So what we need to do is compute the complement, which is 6 or fewer. This is what I meant, Riley, by the -1. Yeah. So if I'm going to find this probability, that's binom CDF. Notice when it's not just one number, but a cumulative number, you use the CDF. I'll have 11.1 and 6. And then once I compute that, I'm going to take 1 minus that value. So if you have that free calculator that you checked out of the library, you have to actually compute this first. So I'll do it that way even on this calculator. So I'm going to go to binom CDF, and I'm going to put in 11.1 and then 6. And this is what I get. So now what I'm going to do is take 1 minus that value. Now, if it's the case that you have to copy this value down on a sheet of paper and then do 1 minus it, that works. So 1 minus 0.99997710003. And we get another teeny tiny number. So again, just to be sure, what I'm going to do is I'm just going to move this decimal point 5 places to the left. And I get 4 zeros in front. And that's the value that I get. And again, if they want you to round to 4 decimal places, 0's a legit answer. Yes. So if you put 0 in for the answer, that's awesome. Then you don't have to convert it.
So, like, so yours came out as.
Did yours just come out like this? Yeah. Right, because your numbers are different, right? Or did you put in these numbers?
And then 1, 2, 4.
Okay. Hold on a second. More lines than I do. No, I mean, this is like little details. All right, finally, when we have at most 10, we can just put that in straight up, binom CDF, 11.1, and then 10. And so, because we probably won't be able to sleep tonight unless we know what this answer is, I will compute it. Oh, look, it has a probability of 1. Is that helpful? want to see if the person that asked, yeah, cool. Cool, good. I'm glad that was helpful. Again, my friends, if you really think that your answer is correct and you're getting marked wrong, it's probably a rounding thing. I can go in and fix that. Yeah.
At most, you wouldn't do it at most 9.
No, because at most means 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10.
What's the other thing?
When it's less than. So if it was less than, that's when you would put 9 instead of 10. No, thank you. Any other questions? So again, just to reiterate, this section in online homework is due tomorrow. Thanks, Rhett, for correcting me. By midnight, okay? And also don't forget that that class activity 5 is due Friday. And while I'm making random announcements, don't forget that next Monday, class is Zoom for everyone. Cool? Okay. You ready? Awesome. Anyone have anything fun going today other than math class? No? Huh?
Hey, Lauren,
Yeah.
I've got a quick question.
Okay.
So can you please go over what less than and at least, like how they differentiate? Because I know with that less, you don't subtract the 1 in front, right? When it's less
Okay.
than.
Okay. So we have, ow, shoot. I don't want to beat myself up here. So we have more than, we have less than, we have at most, and we have at least. This is what you're wanting me to hone in on, correct?
Beautiful.
Cool. Of course it's beautiful. It's a math class. So let's just pretend that for all of these, I'm just going to say more than 10, less than 10, at most 10, and at least 10. Okay. So how would we put this in our calculators? Are you ready? So if I want more than 10, what that means is I want 11 or more. More than 10 means I don't include 10. Okay. So that means that I want 11 or more. Whenever it's a more than or at least, these are when you have to do the 1 minus. So for this one, I would do 1 minus binom CDF NP, and then I would actually enter the 10. Because more than 10 means I don't count 10. To contrast that, if I have at least 10, that means I want 10 or more, because at least includes the number 10. Therefore, my complement would be 9 or less. So for this one, I would put 1 minus binom CDF NP and then 9. All right, are these okay so far? Michael, I think that was you, but I don't know if that was you.
Yeah, no, that's great. That's all I needed.
Oh, do you want me to do these two as well?
You can, but those are just going to be the binom CDF, right? Without the
Yeah,
1
but
minus.
there is a slight difference. So just for the sake of thoroughness, I'm going to do
Okay,
it.
cool.
If
Thank
don't,
you.
Yeah, if you don't want to hear it, just ignore me.
Okay.
My children were really good at that. Okay, so here we want less than 10. When we talk about less than 10, it means we don't want to include 10. Okay, so less than 10 would be binom, CDF, NP, and then 9. Whereas at most 10, again, we're going to the left. We want that or fewer. But when we talk about at most, we're actually including 10. So that would be binom, CDF, NP, and then 10. Is this helpful to lay out like this?
Yeah.
Cool. All right, so what I want to do right now, there was a question to do number 3 in the class activity. I'm not going to do all of number 3 in the class activity today, because I want to be, I'm happy to do it, Riley, this week. But I want everyone to have a chance to work on it because it's really crucial that everybody has at least tried this question before I actually go through it in class, especially going through every single part, because you will be tested on this. So if there's a specific part you want me to go through, I'm happy to go through one of the parts right now. And then I'll go through these things, but I need everyone to have looked at it first before I go through it, because otherwise I'm not helping you learn it. So Riley, if there was one particular part you want me to go through right now, I'm happy to do it. But otherwise I want to wait until later in the week so that everybody's had an opportunity to play around with it. Well, let me know, please. Or perhaps what I might do is make up like a different tree and then do a different tree diagram question so that you all still get to work on this one. Maybe we'll do that. All right, well, what I want to start out by doing is I want to go through 3 examples for this lesson 8, and then I'll make up a tree diagram one at the end. Okay, I just don't want to take this away from everyone having the thoughts and the brain power to work through it, because showing you the answer doesn't help. Cool. Okay. So what I want to do right now is go through a raffle question. Okay. You're going to have 2 of these on your online homework. Okay. So suppose there's a raffle. And suppose there's one first place prize, $400. And there's 3 second place prizes of $80. Suppose each raffle ticket costs $2 and 500 tickets are sold. What we want to do is find the expected payback for a person who buys 1 ticket. So again, you're gonna have a couple of these in your online homework. The number of tickets sold, the cost per ticket, and the prizes are gonna differ, but the basic setup and the thought process is the same. Ready? All right. Well, first off, note, we see the word expected. That tells us that we're going to be computing the expected value. And remember how we went through finding the expected value. We make a probability distribution table, and then you take each X value times its corresponding probability, and you add them up. Do you remember that from yesterday? Oh my gosh, I need to bring like this huge vat of caffeine in here. Okay, I hope you remember that from yesterday. Okay, so the thing is, once you see expected, it means make a probability distribution table, please. Okay? Do you agree that what we want to find is the payback? I'll put that in quotes from the raffle. Right? Because we want to find the expected payback. So let's talk about the various scenarios. Okay? Well, suppose you buy one ticket. What is the best thing that can happen to you in terms of this raffle? You win first place, right? Woohoo! Yes, there's excitement. What do you win? You win $400, but I claim you don't net $400. You know why? Because you paid $2 for a ticket. So yes, you win $400, but what do you really walk away with? You really walk away with $398 because we spent $2 on the ticket. You with me there? Now, again, some of your online homework, the tickets will only be $1. So you'll just subtract $1. Some online homework questions, the cost of the ticket will be $5. So you would subtract $5. You with me there? Okay. You're going to love finding the probabilities on these, by the way. Serious. Okay. What's the next best case scenario? Second place prize. And second place prize is $80. But what do you really walk away with? You really walk away with $78 because you need to subtract off the cost of your raffle ticket. You with me there? All right. Are these the only possibilities? No, there's one other possibility, and the most common of them, in fact. What happens to most people? They lose $2. So most people are out $2, i.e. -2. But really, it's not a loss because raffles tend to be for really good causes. So you can think of it as a really positive donation. Yeah. You with me there? All right. How many people win first place? 1 out of how many tickets? 500. How many people win second place prize? Nope. 3 people win second place. So 3 out of those 500 raffle tickets are second place. Well, if I sold a total of 500 tickets, and 4 of them are winners, right? 1 plus 3 is 4. How many are quote unquote losing tickets? 496. You with me on making this table? Are there any questions so far? Well, now that we have a probability distribution table, we can use the formula that we came up with yesterday to find the expected payback. Now, hold on a second before we actually go through and do this. What's the most likely outcome? Yeah, this is definitely the highest probability. So we're going to expect on average that people lose money. Okay, you with me there? So how do we compute the expected value? Well, remember, your expected value is you take your first X value times its probability plus the second X value times its probability. And I could put plus -2, but I'm just going to write -2 times its corresponding probability. And the beautiful thing about this is you can literally plug this straight into your calculator because it knows its order of operations. So check this out. 398 times 1 divided by 500 plus 78 times 3 divided by 500 minus 2 times 496 divided by 500. And so on average, there's a loss of 72 cents. Did anyone lose exactly 72 cents? No. But remember, when we take averages, more often than not, you get some funky decimal. Kind of like yesterday, we got 2/3 of a purple ball or a purple marble, right? They're solid objects. I guess if you took a hammer to it, you could get 2/3, but I'm thinking too hard about that. You with me here? Yeah? Cool. Any questions on Zoom? All right, so this is one sort of thing you're going to have to do. Now let's talk about a life insurance policy. Yeah. The payback, I'm going to put payback in quotes because losing money is not a payback. But on average, most people are going to lose money, right? Because otherwise, what's the point of doing the raffle? How will they be able to afford to give these big prizes? And then how will they actually bring money, to whatever cause you're doing the raffle for? No, thanks for asking. I really appreciate your questions. Like, I know most people aren't so psyched to be in a math class, but I want you to enjoy this as best you can. Thank you. And maybe my enthusiasm makes up for, like, if we take the expected enthusiasm from all of us and then take the average, hopefully mine will overwhelm a lot of people's negative enthusiasm. All right, life insurance policy. Okay, these computations are done a ton when when insurance companies figure out car insurance, life insurance, all of those sorts of things. They look at a lot of different factors. They look at age, they look at smoking, they look at, various health risks, all sorts of things. Okay. And that's how they determine the amount people will have to pay for the policy. Remember, insurance companies want to make money. Okay. So that's an important thing to keep in mind. Okay. So I'm going to do this problem, but I'm going to do it from a couple different perspectives. So suppose we are find that a person has a 0.00242 chance of dying this year. And actuaries who are statisticians who work for insurance companies, you know, do all these computations. They take all those statistics and compute those things. Okay. So suppose we have an insurance company. Charges, say, $275 for a policy. That pays $100,000 in benefits. We're going to do this twice, and I'm going to show you the difference because you're going to have to do it from each perspective as well. But what we want to do is we want to find the expected value for the person buying the policy. And then what we're going to do is find the expected value from the insurance company's perspective. And then Riley, what I'm going to do is I'll come up with a table question, or not a table question, a tree diagram, similar but not the same as the one on the class activity 5. And I will start class with that tomorrow. Okay. So again, we want to find the expected value, and we're doing it from the person's perspective. So I'm going to let X represent the value of the policy. Well, these probability distribution tables are not very complicated to make. Notice, you're already given the probability, and there's not a lot of variation, right? I mean, there's only 2 scenarios here. Either the person lives or the person dies. Y'all agree? Well, we're given that the probability that the person dies, we're given that 0.00242. Can I get the probability then that the person lives? Yeah. How would we find this probability? Good, you would take 1 minus that value, because there's only 2 possibilities. Either someone lives or someone dies. You with me there? All right. So if this person lives, what kind of money do they come out with? Aren't they out $275? Why? Because they bought a policy that they paid $275 for and they lived. Right? So when you buy an insurance policy, you've spent that money and you don't get anything back. You with me there? Okay. Now, what happens if this person dies? Yeah, their family's like, oh yeah, we'll pretend this person isn't a very pleasant human being. They get $100,000 less the $275 that they spent on the policy. So if the person dies, the family comes away with $99,725. Do you see how I got these values here? Well, we can compute that. We can say that the expected value is negative 275 times 0.99758 plus $99,725 times 0.00242. And you're going to get negative $33. Now, from the insurance company's perspective, the probabilities don't change. Right? The probability that this person lives or dies stays the same. But now let's think about what this table would look like from the insurance company's perspective. If the person lives, didn't the insurance company make $275? Right? So notice from the person buying it, they lost $275, whereas the insurance company made $275. Now, if the person dies, what happens? Well, they made $275, but now what do they have to do? Yeah, they got to pay out $100,000 to this family. So they're out $99,725. So notice the difference if you look at it from the person and their family's perspective versus from the insurance company's perspective. And this is really good to do anyway, because I don't think people look at things enough from other people's perspectives in life to begin with. So this is a good lesson. You with me? All right. So I am going to write one more thing down, and I'm just going to need to leave you with a little cliffhanger for tomorrow. So Riley, again, tomorrow I will totally do a tree diagram, and then I'm also going to answer this cliffhanger. But I still have 5 minutes, so I'm going to use them. Okay, I want to do another expected value problem. This is exciting. Okay, so suppose I give you this silly scenario. Some medication is effective for 92% of the people taking it. Further, suppose it's given to 300 people. How many would you expect to find the medication to be effective? Okay, what's the key word that tells you how you're going to compute this thing? Expect, right? Once you see that word expect, you're going to compute your expected value. So how would we go about doing this? What would be our first step? Make a probability distribution table. Beautiful. Good. Okay. Well, what are all the possibilities then? We could have 0 people find it to be effective, or 1 or 2, all the way to what? 300. Are you wanting to make a probability distribution table with 301 different probabilities to compute? Yeah, I mean, you should be like, are you kidding me? What type of question is this? What type of distribution are we looking at here? We are finding the expected. All right, give me a letter. We're playing hang person. A. Give me another letter. Someone else other than Rhett. Tell me when you've got a guess. I finally got something on you. A D. Hey, those of you on Zoom, you're welcome to participate.
I'll take an F.
An F. Take it up for
Damn.
binomial. Woohoo! You survived. This is a binomial distribution. Yes. Notice. You have a binomial distribution because an experiment is repeated several times. There's 2 possible outcomes. Either it's effective or it's not effective. And the probability doesn't change. It's independent. So how are we going to compute this? Stay tuned for tomorrow. Isn't this great to have a math cliffhanger? Well, if I can somehow get excitement to happen in this class, then I'm doing okay.